Hello everyone, welcome back. In this video, we're going to talk about Monte Carlo simulation of stock prices. So we talked about stock prices follows a particular process. Then in many situations, particularly in situations where you would need to do a numerical computation, then you would need to be able to simulate the stock price process. Now, if you look at it, and this particular process here, the log-normal process we talked about earlier, and you can basically simulate them in two different ways. Well, the more simple way to do that is, this just truncate it, and so anything that's continuous is just make it discrete. So we have, delta s equal to mu s t. Mu again is a parameter, delta t plus sigma s and times this, you draw a random variable under the normal distribution with 0 mean and 1 as the variance, and times square root of delta t. Oh, so then your st plus 1, the stock price in the next time step, then is the current stock price plus this delta t that you simulated randomly. The other way to calculate to simulate stock price is really to say that, okay, I have this particular stochastic process, and I know this stochastic process has the log of this s of the price s here follows a normal distribution. And so I can explore the fact that we talked in the last video, log as t, the bigger t, in this case, you can that will be the stock price in the next time period, follows a normal distribution with the mean being log as t, the little t, plus this sigma mu minus half sigma square delta t term here. And the variance of that normal distribution is sigma squared delta t. And to update that as t plus 1, so the price at the next time period is really e to the power of log as t plus 1. Okay, so now you essentially have two different ways of calculating the to generate a simulated stock prices for any given initial stock price value. Well, which one is more preferred? And particularly when you probably will have a relatively large delta t. So if you calculate, for example, the options for a particular stock, and for a period of say 1 year, and you can choose a weekly time steps, or you can choose a bi-weekly time steps, or even you can choose a monthly time step. So if time steps are relatively large, and which one will give you a better result? Well, think about it. In this case, however, that if you utilize the distribution here, you will actually get a much more robust result. Let's say you just have one step, right? So if you do a calculation, and you need to simulate the realized price 1 year from today. And if you just do a one-time step, you can just draw directly out of this distribution here. Whereas if you use this discretized process, and just draw, make delta t being 1 year and draw this delta s, you would tend to have much bigger errors than what implied from this distribution. So if this is very small, if delta t is very, very, very small, you will actually recover this distribution. Okay, but if your delta t is relatively big, you will have a hard time to recover the actual distribution that the stock price will experience, or the stock price will follow, because this stock price actually follows a continuous time process here. So in this case, you should use the distribution actually derived from that stochastic process. Okay, I'll stop here. I'll talk to you in the next video.